So there's one more transformation of sine and cosine graphs that we still have to look at, and then we'll also look at tangent graphs. So with sine and cosine graphs, we did vertical and horizontal stretches. We changed the amplitude and the period. And we also did vertical shifts. We shifted up or down. We also did reflections. We reflected it across the x-axis. We don't really look at reflections across the y-axis much for sine and cosine graphs. The one other thing that we do look at is what we call a phase shift, which is a horizontal shift. Again, sine and cosine graphs show up all over the place in the real world with sound waves, electricity, all kinds of other things. And so they've got all kinds of terminology for sines and cosine graphs because people work with them so much. And so if a sine or cosine graph, called a sinusoidal graph, is shifted horizontally, it's called a phase shift. So if you ever hear of sound or electricity or those things being like out of phase, it just means that it's a trig graph that got shifted horizontally. So just like with the vertical shifts, though, we're just going to do it in two different steps. We'll do it without the shift, and then we will just go ahead and shift all the points. All right, so first, we're just going to sketch y equals 0.5 sine of x. That x minus pi over 4 inside the function is going to shift it horizontally. So we'll do just this first. Okay. So remember, the important thing is always make sure you know whether you're doing sine or cosine. Make sure you know where you're starting your graph. Okay. Sine of 0, 0. So we're going to start at 0. Okay, and then normally the graph would go, and then our period here. So one thing with our period is not going to change in terms of the length. So it's going to start and stop at different places because we're shifting right. So the normal period here. So again, right now we're just sketching this function here. We're just sketching 0.5 sine x, which the period hasn't changed. The period is still 2 pi. And so we're going to start at 0 and then stop at 2, 5. Now those are going to get shifted, so we're going to start and stop at different places, but the length of the graph will still be this period of 2 pi. And this one that we're graphing right now, certainly there's nothing inside the function next to the x. Nothing's changing the period, so certainly this function, the period would just be 2 pi. Okay, so we're going to start and stop here. And the scale for that normal graph was pi over 2. If you take 2 pi, divide it in 4, you would get pi over 2. You could look at halfway in between is this, and then halfway to there is here. And so your points would be at each of those hash marks there. All right, and so normally we would go up to 1 for the next point there, but because of this 0.5, our amplitude is just 0.5, it's just a half. So instead of going up to 1, just going to go up to 0.5, and then we'll just do that bouncing around pattern, right? We've gone up to the top, so now we need to go back to the middle and then keep going till we get all the way down to the bottom of the graph. Again, we're going between 0.5 and negative 0.5 because 0.5 is our amplitude. This was a vertical shrink. We shrunk it vertically here. So those points would be the points we would use for this graph. And then we're just going to take each of those points and shift them. All right. So hopefully you remember these kind of shifts here. One way that we looked at it was we thought about, okay, if this was like a factor of something that we were solving, what would be the x value that we would be looking at as a solution? We would get x equals pi over 4. Pi over 4, that's a positive x value, so it's on the right side. Of course, you could also just memorize that the ones with minus were shift right. They were kind of the ones a little bit maybe backwards of what you expect. A minus inside the function shifts it right. And so we're just going to take all those points and we're going to shift them right pi over 4. Okay. So well, our scale here, so here's pi, and then I've got 4 lines here, and so pi divided by 4, each line for me here is pi over 4. Remember this scale right here, this was pi over 2, and so what I'm going to do is I'm just going to take this point, move it halfway to the next one here. This line right here is pi over 4, so move this over here, move that over there. Every point is just going to move right one grid line because each grid line for me here is a space of pi over 4. Right? And then I can just connect the dots. Usually one period is enough for us. And there's our graph. That's it. Okay, so just like vertical shifts, you can make it a lot easier on yourself if you sketch it without the shift, and then just take every point and move it. Okay? If you wanted to try to do it in one step, you would have to think about what these starting and stopping points would be, and then kind of figure out where the other points are going to be. You could do halfway in between, and then halfway in between that, and place your points that way. But a lot easier just to do it in two steps. Okay, and again, the period is still 2 pi. This length right here, this length is still 2 pi. It starts and stops at different places, but the length of the graph hasn't changed. I took a length of 2 pi and I moved it to the right. Okay, so why don't you go ahead and try one of these here. Go ahead and try this one. This one is also going to have a phase shift, a horizontal shift. Again, I highly recommend that you try sketching it without that first. And then just take every point and shift it. See if you can see what that'll look like. And then also, I'd like you to see how much of the graph of tangent you can figure out on your own. Again, anytime that we want to graph something that we're not sure about, we always can just go back to making a table, plugging in points. Right? And so this is the table that I'd recommend trying to fill out there. And then see if you can plot those points, see if you can have any idea what the shape of the graph might look like. Tangent's going to be a little bit different. Sine and cosine were very, very similar, right? Tangent's going to look a little bit different. So go ahead and try this problem here, sketch that function with that phase shift, and then see how much of the graph of tangent you can figure out all on your own. Fill out this table, fill out that table, and see if you have any idea what the graph might look like. All right. So this one was a shift left, pi over 2. Again, if you solve that inside part there equal to 0, you get negative pi over 2, or just memorize that minus inside is right, plus inside is left. Um, and so I sketched it without the shift first, and then just moved everything left pi over 2. So for me, left pi over 2 was 2 grid lines, how I had my graph scaled there. This first point over here was at pi over 2, so moving it left pi over 2 moved it over to the y-axis. And then this point here moved to where that point was, because each point was spaced at a distance of pi over 2. We went over pi over 2 between each point, and so if we move it back pi over 2, then we go back to where the previous point used to be. All right, so your graph should have looked something like that. Again, the length is still 2 pi right here. This one actually does still have a period of 2 pi. This length is still 2 pi. It just starts at negative pi over 2 and ends at 3 pi over 2. All right. All right, now how about tangent? All right, so we fill out this table and there were some undefined places, right? So that's why you might have noticed that we did more in our table for tangent than we did for sine and cosine. Let me see if I can grab my notes from when we did sine and cosine here. Yeah, here we go. For sine and cosine, all we had was the quadrantal angles, right? And that was enough to see the shape of the graph. For tangent, though, if all we had was the quadrantal angles, take a look at this. Try to cover all these up here. If all you had was the quadrantal angles, you wouldn't have a lot, right? If you just use the quadrantal angles, all you would have would be a bunch of zeros and undefineds. That wouldn't tell you a whole lot about the shape of the graph. So that's why we added some other angles into this table here. We said, all right, well, the quadrantal angles, that doesn't give us enough, just zeros and undefined. Okay? We need some other angles that will give us some nice points. And we chose pi over 4 because all those pi over 4 angles, the ones that have pi over 4 as a reference angle, all of those, the tangent is either 1 or negative 1. Because pi over 4 has the same x and y coordinate on the unit circle, right? So y over x, if y and x are the same, then tangent ends up being 1. So pi over 4 angles give us some nice points for tangent. So we put that in there. And so now we've got kind of this collection of points here. But we also have to deal with this undefined here. Well, undefined can just be like the little hole in the graph, the removable discontinuity. but probably more often than not, undefined is going to mean we have an asymptote. Right? So what we're going to have at pi over 2 and 3 pi over 2 here, we're going to have a vertical asymptote. So if I fill this in, if I fill in these asymptotes, now take a look at what we've got. Okay? We've got some points, and then we have to approach these asymptotes. So take a look probably maybe at this section here. See if you can see what the graph is going to maybe look like. We have to go through those points, and then we have to approach the vertical asymptote. We have to start looking really, really close to a vertical line as we get close to there. So the shape of this, so down here, it has to almost be a vertical line. And then we have to go through those points, and then we have to approach this vertical asymptote. It's a shape somewhat similar to the cubic graph, right? Except the cubic graph would go out to the sides forever, right? And the cubic graph goes up and down on the sides there, but also we keep going to the left and right forever. This one has these vertical asymptotes there. But in terms of this kind of left and right going down and up there, the shape is a little bit similar to a cubic, right? So let's take a look at this. So this one here, well, this section would go like that, and then this section would go like that. Now notice for sine and cosine, both of them, the period was 2 pi. We had to go to an angle of a full circle before it started repeating. With this one, did we have to go all the way to 2 pi before it would start repeating? Or does it start repeating any earlier? It does start repeating earlier, right? Take a look at this. We had 0 here, then we get to 0 here. We have positive 1 there, positive 1 there. Vertical asymptote here, vertical asymptote there, -1, -1, 0, 0. This one starts repeating earlier, okay? This section right here is the same thing as that section right there. Okay, so we actually only need to go to pi for this one. Tangent has a period of pi. This is going to be something that's important to keep straight, because sine and cosine, the period was 2 pi, right? So you're really going to have to keep those straight. Sine and cosine, the period was 2 pi. Both sine and cosine, the period is 2 pi. But for tangent, the period is pi. That's something different. Okay. So, I mean, we could look at this as one section of the graph, one period, and that would be true. But it's kind of a weird looking section of a graph, right? So what we often do is instead we keep this going to the left side there. We say, okay, negative pi over 4 would have a tangent of -1. And negative pi over 2 is coterminal with 3 pi over 2. It would also have an undefined tangent. And so the graph could keep going like that. And so what we usually do is we look at this as one period of the graph. So we have vertical asymptotes at pi over 2 and negative pi over 2. And so the distance from one asymptote to the other is a distance of pi. Right? Now this is something else people will get confused on. So first of all, people will forget that the period's not 2 pi, the period's just pi. But then they'll also get mixed up on, they'll think that pi is where the asymptote is, but it's not. Pi is the length from this asymptote to this asymptote. We've got a distance of pi over 2 on each side of the y-axis. A distance of pi over 2 here, a distance of pi over 2 there. That makes a total distance of pi. So even though the period is pi, the length of this graph is pi. The asymptotes where it's going to end is at pi over 2. But that's what the graph of tangent looks like. And like the other ones, it will keep going on forever. This will just keep repeating. It is periodic. It does have a period. It does have a length that repeats on forever. Okay. Let's see. What about the domain and range? So for sine and cosine, the domain was all real numbers. What about tangent? Does the tangent graph have a domain of all real numbers? It doesn't, right? It has these places that are undefined, right? So we can say all real numbers, not equal to, we'll just kind of put this in quotes here, pi over 2s. In chapter 5, we would learn a more formal way to express something like this, but right now we'll just kind of express it informally. Any kind of pi over 2 angle, pi over 2, 3 pi over 2, 5 pi over 2, negative pi over 2, anything like that. Any of those angles that would be straight up or straight down, the unit circle, any of those is going to make your tangent be undefined. And so we have an infinite number of asymptotes, an infinite number of undefined places on the graph. All right, what about the range? What about our y values? Well, the range, I mean, even just this one section here, we've got all real numbers, right? The y values go all the way down and all the way up. So our range is all real numbers. So sine and cosine were trapped between -1 and 1, right? Do you remember that? Sine and cosine had the range of -1 to 1. Sine and cosine were the x and y on the unit circle. Farthest you could go is out to -1 or +1. Sine and cosine of any angle in the world have to be a pretty small number, but not tangent. All right. So if you want a trig function of an angle to be something like 7, it's got to be tangent. If you're doing sine or cosine, you can only have things like 0.7 or 0.83 or things between -1 and 1. Okay. All right, so that's the base graph of tangents, and then just like everything else, let's do some transformations. All right, so about 5 tangent of 2x. Let's see, it looks like I'm missing a grid there. So let me find the extra grid. Okay. So if we want to do this one here, so the 5, what that's going to mean, let's see, I'll have to scale this a little bit differently here so this will fit. Let's go ahead and make this be 5 right there. What that 5 is going to be doing is we don't have an amplitude for tangent, but it kind of functions like the amplitude. So it's going to be where we had those kind of special points. So we had these special points from our pi over 4s here used to be at -1 and 1. Now instead of -1 and 1, now they'd be all the way up and down at -5 and 5. They'd be off that grid that I had at that point. And I changed my scale here so I could even fit them. So what we're still going to have the point at 0 in the middle, and then we're going to have some points on the side at -5 and 5. Now we have to figure out where those are, though, right? Let's take a look at our period. Right? So remember, normally the period for tangent is pi, right? Well, now what I need to take a look at the inside here, set that equal to pi, and so now my period is pi over 2. Okay, well, remember that's the whole length from one asymptote to the other. I'm going to have an asymptote on the left, and I'm going to have an asymptote on the right. And so, well, if the whole length needs to be pi over 2, then how much am I going to have on each side? I'm only going to have pi over 4. So this one's going to get kind of squished in here. So we're going to have a length of pi over 4 here in order to have the whole period be pi over 2. And so my asymptotes are going to be at pi over 4 and negative pi over 4. Okay? The period is not the same place as where the asymptotes are. These asymptotes are at pi over 4 and negative pi over 4. So that I have a length of pi over 4 here, a length of pi over 4 here. Pi over 4 plus pi over 4 gives me a total length of pi over 2. The period is the length, okay, which is a little bit trickier for tangent. Okay? All right, and so then I have to have the special points there, okay, halfway in between. So for this one here, I didn't even have tick marks for it. I'd have to add in the extra tick mark there. I'd have to say at pi over 8 is going to be where this point is right there. And then at negative pi over 8, I'm going to have that point right there at -5. So halfway between the origin and the asymptote, I have these points. Normally at 1 and -1, I've multiplied it by 5. I've vertically stretched it by a factor of 5. So now instead of -1 and 1, now they're -5 and 5. And then I still have this same shape here. Go through those points, and it looks something like that. All right, let me go ahead and show you. I don't know why that grid didn't print well. Let me go ahead and show you on the copy that I'd printed before. I made a different grid that would fit this one on a little bit better. This is what it would look like if we had a grid that would fit it better here. We'd have those asymptotes at -π/4 and π/4, and then these points at -5 and 5, halfway in between. Again, this was π/8, and this was -π/8. Halfway in between, we've got to have those nice exact points. All right, so now why don't you go ahead and try one of these for call it quits for this lesson. Take a look at this one. Notice there's a negative out front there. I'll let you try to think about what a negative tangent graph would look like, that reflected about the x-axis graph would look like. You go ahead and try to sketch this graph here. Right, so this is what this one would look like. So we had a period of 2 pi. So we took x/2, set it equal to pi. That gives us a period of 2 pi. That's the length from this asymptote to this asymptote. So that meant the asymptotes actually had to be at pi and -pi. Distance of pi here, distance of pi there makes a total distance of 2 pi for our total period of 2 pi. And then because of this 0.25 here, our points, instead of being at 1 and -1, now they're at 0.25 and -0.25. And the negative, again, reflects it across the x-axis. The negative on the outside affects the y's. We've got opposite y values. All the y values change sign between positive and negative. So instead of going like this, it flips upside down and goes like that. I multiply -1 and 1 by -0.25, and -1 changes to +0.25, +1 changes to -0.25. And that's the graph. Just one period, right? There would be lots more of these. These would keep going on forever. They would keep repeating, but usually just sketching one period, that's often enough.